How are you? Simple harmonic progressive wave which is always traveling in the forward direction, and it is of two types: transverse wave and longitudinal wave. We studied the characteristics of both the transverse and longitudinal waves. Then there was a superposition of waves. When two or more waves arrive at a point of a medium simultaneously, then each wave produces its own displacement independent of the others. And the resultant displacement at that point is the vector sum of displacements due to all the waves. That was principle of superposition of waves. The physical effect of that superposition is called interference, and we saw different examples of superposition: constructive interference, where the amplitudes get added; destructive interference, where the amplitude gets subtracted. In constructive interference, you hear a loud sound of constant amplitude. In destructive interference, you hear a low sound of constant amplitude. This happens when the frequencies of the two interfering waves are same. But when the frequencies of the two waves are different, there is formation of beats, alternate rise and fall in the resultant intensity of sound. So beats was the third example of superposition. Another example of superposition is formation of stationary waves. Stationary waves is an example of superposition of waves. If you consider two exactly identical waves, two exactly identical waves, exactly identical means having same period, frequency, and same amplitude. So if this is one wave, इसका ये amplitude है, second wave has got same amplitude, their wavelengths are same, and their periods are also same. So two exactly identical waves means two waves having same amplitude, same frequency, and same wavelength. So two exactly identical waves, if they are traveling along the same path, एक ही रास्ते पर दोनों चल रहे हैं, two exactly identical waves traveling along the same path but in opposite directions. Two exactly identical waves traveling along the same path but in opposite directions. When they interfere with each other, when there is superposition of these two waves, then stationary waves are formed. That is the definition of a stationary wave. Stationary waves are produced when two exactly identical waves means having same amplitude, same frequency, and same wavelength. Two exactly identical waves traveling along the same path but in opposite directions interfere with each other. Stationary waves are formed when these two waves traveling along the same path but in opposite directions interfere with each other. The best example of two exactly identical waves traveling along the same path but in opposite directions is incident wave and reflected wave. Suppose if a wave is incident on a surface perpendicular and gets reflected, then this incident wave and the reflected wave both are exactly identical. They are having same amplitude, same frequency, same wavelength, and they are traveling along the same path but in opposite directions. So if you consider, suppose, a string tied to a wall, Suppose this is a stretched string. Stretched string means it is under tension. That is very important for waves, because the velocity of wave on a string, the velocity of transverse wave on a string is given by V is equal to under root T by M. If there is no tension in the string, wave will not be formed. Velocity will be equal to 0. So this is stretched string, means it is under tension. Suppose if you move this string up and down, then a wave is created here which travels to the wall. From there, it will get reflected. The reflected wave will be exactly identical to this wave. So there is a superposition of the two, and stationary waves are formed. This is a stationary wave. Loops, ये ऐसे loops बनते हैं. In stationary waves, there are loops like this. So this is transverse stationary wave. Similarly, there can be longitudinal stationary wave, sound wave, but the longitudinal wave can also be represented in this manner. We have seen this कि अगर wave हम ऐसे बता रहे हैं, this may be a transverse wave, this may be a longitudinal wave. Both are represented like this. So this we showed the transverse wave on a string. Same diagram can be drawn for longitudinal wave also. So in a stationary wave, loops are formed like this. So this is a stationary wave. There are loops in that wave. You'll find that at some points the displacement is 0. The point is not moving. At some points the displacement is 0. At some points the displacement is maximum. Amplitude is maximum. And in between these 2 points, the displacements are different. Every particle is having different displacement from the mean position. So the points which are not moving, these points, point of 0 displacement in a stationary wave, the points of 0 displacements are called nodes. And the points of maximum displacement are called antinodes. So in a stationary wave, there are alternate nodes and antinodes. Node, antinode, node, antinode, node, antinode, and so on. So in a stationary wave, there are alternate nodes and antinodes. The points of 0 displacement are called nodes. The points of maximum displacement are called antinodes. And the big difference between a progressive wave and a stationary wave is in its name. Progressive wave is progressive, it is always traveling forward, and stationary wave is stationary, standing, it is localized. Means in a progressive wave, energy is moving, energy is transferred in the medium from one point to other point. But this stationary wave, as it is localized, it is stationary, means energy is there, but that energy is stationary, it is not transferred. That is the big difference between a progressive wave and a stationary wave. Another difference is that in a progressive wave, the amplitude of every particle is same. मीडियम के हर पार्टिकल का एम्पलीट्यूड सेम है. जैसे ये है एम्पलीट्यूड, दिस पार्टिकल हैज कम अप टू हियर, दिस पार्टिकल इज हियर, यहां पर है, लेकिन वो यहां पर रहने वाला नहीं है. इट इज गोइंग टू मूव अप टू दिस मच, राइट. ये वाला पार्टिकल भी यहां तक जाने वाला है. जो पार्टिकल 0 पर है वो भी यहां तक जाएगा. Means every particle is having same amplitude in a progressive wave that we have seen. In a stationary wave, it is not so. Different particles are having different amplitudes. जो जीरो डिस्प्लेसमेंट पर है नोड, वो हमेशा जीरो पर ही रहेगा. इट इज नॉट गोइंग टू मूव. मतलब ये ऐसे वाइब्रेट होने वाला नहीं है. जीरो डिस्प्लेसमेंट पॉइंट विल ऑलवेज रिमेन जीरो डिस्प्लेसमेंट. उसका एम्पलीट्यूड जीरो होगा. दिस पार्टिकल इज हैविंग मैक्सिमम एम्पलीट्यूड. इसका एम्पलीट्यूड हमेशा इतना ही रहेगा. इट इज नॉट गोइंग टू चेंज. यहां वाला जो पार्टिकल है वो यहां तक गया है, वो इससे ऊपर नहीं जाएगा. वो यहां से यहां तक ही जाएगा, नीचे आएगा और ऐसे ही वाइब्रेट होगा. इट विल वाइब्रेट लाइक दिस. इतने ही डिस्टेंस में वाइब्रेट होगा. मतलब उसका एम्पलीट्यूड इतना ही है. सो डिफरेंट पार्टिकल्स आर हैविंग डिफरेंट एम्पलीट्यूड्स इन अ स्टेशनरी वेव. दैट इज अनदर बिग डिफरेंस between a progressive wave and a stationary wave. So number one, progressive wave is progressive. It always moves forward. It carries the energy is transferred. Stationary wave is standing. It is neither moving forward nor backward. Means energy is localized. Energy is not transferred. First point of difference. Second point of difference, in a progressive wave, every particle is having same amplitude. Every particle is having same amplitude. In a stationary wave, different particles are having different amplitudes. The amplitude at the nodes is zero, and the amplitude at the antinodes is maximum, and for other particles it varies between zero to maximum. इसका amplitude इतना है. ये zero amplitude, इस particle का amplitude इतना है. अगले पार्टिकल का एम्पलीट्यूड उससे ज्यादा है. नेक्स्ट पार्टिकल का एम्पलीट्यूड उससे ज्यादा है. एंड एंटीनोड इज हैविंग मैक्सिमम एम्पलीट्यूड. सो डिफरेंट पार्टिकल्स आर हैविंग डिफरेंट एम्पलीट्यूड. सेकंड बिग डिफरेंस बिटवीन simple harmonic progressive wave and stationary wave. Third big difference is that in a progressive wave, every particle is having different phase. We have seen that again. कि हर पार्टिकल का फेज क्या होगा, अलग होगा. आगे वाला पार्टिकल पीछे वाले पार्टिकल से पीछे होगा फेज में. द नेक्स्ट पार्टिकल इज लैगिंग बिहाइंड इन फेज देन द प्रीवियस पार्टिकल. इन प्रोग्रेसिव वे एवरी पार्टिकल इज हैविंग डिफरेंट फेज. इन अ स्टेशनरी वेव ऑल द पार्टिकल्स इन वन लूप आर हैविंग सेम फेज. एक लूप में जितने भी पार्टिकल्स हैं सबकी फेज सेम है. ऑल द पार्टिकल्स इन वन लूप आर हैविंग सेम फेज, एंड द पार्टिकल्स इन द नेक्स्ट लूप आर इन द ऑपोजिट फेज. ऑल द पार्टिकल्स इन वन लूप आर इन द सेम फेज, एंड द पार्टिकल्स इन द नेक्स्ट लूप आर इन द ऑपोजिट फेज. थर्ड बिग difference between progressive wave and stationary wave. There is one more point of difference, very important, but that we shall see after going through the equation of a stationary wave.